Okay, welcome back. This is the final topic of this fifth section of this class. So this is what's called proving parallel lines. It's very, very similar to what we did in the last section. It's just showing that things are parallel by setting certain things congruent or adding up to 180. Okay, so all these postulates you're going to see are just the complete opposite of what we saw before. So it's called the converse of corresponding angles postulate. It says if two lines are cut by a transversal so that each pair of angles is congruent, the lines are parallel. And the one in the last section said they are parallel, then those things are congruent. So it's the backwards of this. So basically what they're telling you is if angle 2 and angle 3, sorry, these are corresponding, angle 2 and angle 4, if those things are congruent. So let's say this was 50 and this was 50. If they were congruent, that would prove that those two lines are parallel. And in the last section, we had to first tell you they were parallel before we solved for the problem. Okay, so it's just the inverse or the reciprocal of what we did before. Alright, the second one is the alternate interior. It says if two lines are cut by a transversal so that each pair of alternate interiors are congruent, those lines are parallel. Okay, same idea. They're not parallel unless they are congruent. Consecutive interior is if these things are supplementary. They add up to 180 degrees. Remember, consecutive interior means next to each other on the inside. They are parallel. Alternate exterior, if those things are congruent. Okay, alternate exterior, we're across the transversal on the outsides of the lines, then those lines would be parallel. So in this section what we're going to be doing is finding the values of the variable to prove that they are parallel. Alright, so here's how that works. I've got these two angles here. Okay, now based on these two angles, which of these relationships, alternate interior, alternate exterior, corresponding, consecutive interior, which one are they? Well, they cross over the transversal. They're on the outsides of the lines that appear to be parallel, so that would be alternate exterior. And alternate exterior are congruent, meaning they're equal. So we set them equal and solve it. So subtract 2x, add 14. So those cancel, I've got x equals 39. So what that says is if x is equal to 39, then they're parallel, and that's what they want you to find. And this would be true because of alternate exterior angles. Now if you think of some of the other possibilities, if I were to move that this way, which is allowed because they're vertical, then I would have this angle and this angle. Those are corresponding. They can still be set equal, and you'd get the same answer. Your reasoning might be a little different. You'd have vertical and then corresponding, but it's still going to get you that same answer. Alright, for this second one, I want you guys to pause the video, try and decide what type of angles those are, and find the value of x that would prove they are parallel. Alright, so hopefully you guys had enough time. You paused that video, you found this out. So if you look at those two things, those are consecutive interior. So consecutive interior, you've got 7x minus 2. You've got 10x minus 3, or 10 minus 3x. Now what this property says is the only way that these things are consecutive interior is if they are supplementary, meaning I add them up to 180 degrees. Alright, so we go through and we solve this. First step, combine your like terms. So 7x minus 3x is 4x. Negative 2 plus 10 is 8, equals 180. Subtract 8. That gives you 4x equals 172. Then you take the 172 and you divide that by the 4. And you get x is equal to 43. And the reason would be consecutive interior, and there's your answer. Alright, so those are some of those things that we're going to be looking for, and just testing to see if we can prove one way or another that they are parallel. Okay, so you got to just kind of work through and see which angles you're given. Alright, final thing for this section is just to work through a two-column proof. Alright, so we start this proof the same way we start every proof, knowing what is congruent or what is given. Okay, so this is given. Angle 1 is congruent to angle 2. There and there. They want us to prove that line L and line M are parallel. Alright, let's think of how this works. Well, angle 1 and angle 2 are alternate exterior angles. Okay, we know that. We could say that angle 2 and angle 3 are vertical angles. Okay, so we'll say that that's the vertical angles are congruent. Alright, and that's true. We know that. Because of that, we've got angle 1 congruent to angle 2, angle 2 congruent to angle 3. So angle 1 is congruent to angle 3, and that's your transitive property. Okay, so because of the transitive property, that's true. And now it's a pretty simple explanation. If you think of L congruent or parallel to M, the reason is look at where angle 1 and angle 3 are. Angle 1 and angle 3 are congruent, and so what that means is corresponding angles are congruent, lines are parallel. And really all that is the converse to corresponding angles theorem. And there you go. Now really, if you think about it, them giving us angle 1 or congruent to angle 2, is that enough? Well, yeah, because they're alternate exterior. So you could have gone from the first step straight to your conclusion and just said the alternate exteriors are congruent, then they're parallel. And that's another reason. Okay, so there's more than one way to do this proof. I hope you guys understand that by now. You've seen enough of these proofs that that should be something you guys recognize. Alright, give your homework a try. If you have some questions, let me know. Okay, and we'll talk to each other in the discussion. Talk to you soon.